I'm a 48-year-old aerospace engineer, and I graduated from San Diego State University with a Bachelor of Science degree in mechanical engineering. I specialize in composite manufacturing. I've been doing similar type of work for the last 25 years. And in those 25 years, I've worked on lots of radome, lots of optical benches, lots of antenna structures, a lot of lightweight structure. But in recent years, the last 5, 6, 7 years, I've done a lot of ground system work as well. I've worked on composite armor, believe it or not, for the Crusader vehicle, which is part of the future combat system. Unfortunately, for budget cutbacks and stuff like that, didn't bring that program to production level, but we've done quite well. We've gone on to other type of armor. Recently has been polypropylene, polyethylene with Kevlar, Dyneema, those type of materials. So you'll see in later clips of the video of the things that I'm into, bicycling, recumbent trikes, and velomobiles. That's the kind of stuff that I do that is very similar to work. I've been able to make these type of hardware, building it myself and processing it in my own shop. And I've done things such as building my own oven and pressure vessel in order to replicate what it is that I can build at a facility like Applied Aerospace, which is a very high-tech manufacturing facility, all the way to modifying existing vehicles for my own personal requirement. And you'll see that even though it is sort of a tinkerer's approach, I can build hardware that rivals that of the same hardware that Applied Aerospace, my employer, is able to do, because as a research and development engineer, I'm familiar with all their processes. In fact, I'm the guy that is called when there are manufacturing issues and things that needs to be resolved and new material to be evaluated. I'm the guy that they come to in order to get this done. Anyway, so I take advantage of the material that I have access to, and in building some of the toys and equipment and things like that for my own personal use. Obviously, it's much easier if you have your own oven and pressure vessel, and I've done that. I actually went out and have these things built and put it in my shop and able to process these things. The same process as is done at Applied Aerospace, just in my man cave. Besides work, tennis is a sport I played in high school. I played a little bit in college. Never good enough to get myself a scholarship. Right now, I'm getting my son trained. I have him taking lessons, and right after lessons, I jump in there and try to maximize the lessons learned and built in order to make parts that requires up to 60 psi during cure. And I use this as an oven to heat up and cure the components that had been placed into that pressure vessel in order to stir up the air around in the box. I've put this external motor here and extended the shaft to turn the fan inside the foam box. This allows me to have the convection I need without subjecting the motor to high temperature, so I can use a relatively inexpensive motor. This is how I've been able to replicate the capability of an autoclave and be able to do that at home. The fan that I talked about on the through shaft, as well as the heating element. This heating element is merely an heating element that goes into an electric dryer, and I run 2 of these for the oven. Cave, You can see here that I've got a couple of recumbent bicycle hanging on the wall. Action mat. This is my fastest two-wheel ride right here, recumbent position. The Bike E, which is a good all-around neighborhood type bicycle. We have here an EZ3 three-wheeler. You can see that I've added the rack system back here for my panniers when I ride this thing to work. A 24-volt seal lead acid battery pack that powers a 500-watt electric motor. The items that you see in aluminum there is something that I have designed and built in order to mount that little motor that was meant for a mountain bike. I adapted it for use on this trike. I've gotten about 2,000 to 3,000 miles on this trike as a way to get to and from work. This is something that I ride to work these days, waiting for my velomobile to be completed. This used to have a 350-watt assist system, but I find it wasn't necessary. It's a lightweight bicycle and keeps me in better shape when I actually do the pedaling. So about 25 miles round trip each day is what I do on my commute. And of course, the Cadillac is nice too when it rains. Project. This is the latest right here. My buddy Dan and I are building this beast right here. It's basically called a velomobile. Full suspension, three-wheel transport system. In this case, it's going to be human powered. You can see by the bicycle drivetrain here, the chain snake around through the bottom, coming back here. This is an internally geared hub from Sturmey Archer. It has built-in drum brakes. And you're going to see drum brakes up here as well, 90 millimeter, also from Sturmey Archer. McPherson strut type. And this is the only vehicle of its kind because the original design called for sheet aluminum all through the construction. Everything that you see in green here is aluminum, has been primered, and everything you see in black is made out of the same material that we use in the program called Taurus 2, which is a resupply vehicle for the space station. This thing will also be supplemented with electrical power, 500 watts, cyclone system that's going to be powering through the gear, and it will be motivated by a lithium ferrous phosphate battery from Life Bat.